See, the square matrix is basically mapping from same vector to, so it's like same dimensional vector, right? When I say dimension, it's not the dimension of the map linear. So basically, the matrix that we're talking about is the number of elements in the vector itself. So if it is rectangular, that basically means 3 का 4 पे मैप हो रहा है या 3 का 2 पे मैप हो रहा है. But अगर 3 का 3 पे मैप हो रहा है तो स्क्वायर मैट्रिक्स ही होगा, right? So linear transformation is not just bound to mapping a same vector element, like it's bound to mapping, similar dimension vectors. It can map, 3 का 2 as well. So yeah, so not rectangle like matrices can exist, yes. Hello.
So can a non-square matrix be invertible?
Can a non-square matrix be invertible? Yeah. So I mean, see, it can't be, because I think when we talk about non-square matrix, either one of the dimension has to collapse, right? So let's suppose if we are taking a 3 to 2 or 4 to 3, that means basically there will be a lot of vectors that will be mapped to the same vector, maybe a point or a line, right? So
Okay.
inversion means, so when we say surjectivity and injectivity has to be a property of inversion, उसका मतलब क्या है कि like every, like whatever images that you can form from the source to target, so everything in the target has to be mapped to something unique, right? Now if I take a, let's suppose a line in the target, we know that that particular line came from lot of vectors which collapsed onto that line, right? So if I ask you, okay, this was the line, can you tell me कि किस original vector से आया था, you wouldn't have a unique answer. You would have multiple solutions for that, right? So in the inversion उस case में you, it's not basically defined itself. मतलब आप inversion term use करना is basically illegal, मतलब गुनाह है, ठीक है? So this question itself,
Okay.
it becomes yeah. Yeah,
So
Ritesh.
once we assume that it is a square matrix, then the number of linear columns will be equal to the rank, and that is also equal to the number of linearly independent rows. So that is by definition of the rank of a matrix.
Yeah, I think it makes sense now. So yeah, I mean, see, okay, so rank of a matrix. So basically when we say rank, right, I think I'm pretty much sure it's defined as column rank and row rank, not just.
Yes, but they are always equal. Can you Google a few?
Okay. So what do you want me to Google? Row rank and column rank?
Yeah, the definition of rank of a matrix and if they are equal.
Yeah, so rank of a matrix is like I said, right? It's basically the basis number of basis vector, I guess. I think. 1 second. Okay, yeah,
So
sorry. It's basically massive
column
number
or
of linear.
rows.
Okay.
So it says the columns or rows are linearly independent only if the matrix is non-singular. So
Yeah.
it means both of them have to be linearly independent. Right. So if we take a transpose, then still both of them will be linearly independent.
Okay, so I think let me cover this rank thing after this class. Let me look into this. But yeah, I mean, essentially what like whatever is based on this, it's written. So maximum number of linear independent columns or rows of a matrix is called a rank of a matrix. I can see, basically you have, if it's a square matrix, and if it's basically the rank is same, then I think it has to be I mean, you cannot have something which is dependent on in that particular matrix. That is fine, but I think still I'll just look into it and maybe give you a proper explanation in next class. But yeah, still that doesn't explain, Ritesh, that why taking a transpose first and then inverting will give us essentially the effectively the same map as taking an inverse and then doing the transpose. How does this explain that?
Yeah, that's why I said the first half it explains a lot. For second half, I think it needs something more.
Okay. ठीक है. So I'll come back to this rank and this particular linear independence concept maybe like once I revisit that myself. But yeah, I mean, I think we can discuss that this particular thing maybe again tomorrow, I guess. Actually, I think it must be, yeah, it's already here. I think I just thought I had covered this, so I didn't go through this again. But okay, so let's look into change of basis. So like I think we had discussed, right? So basis is something which is basically minimal set of linear independent vectors that can span the space, right? And I also told you, right, the basis that this thing is not unique, although the dimension of the basis is dimension of the basis, dimension of space, no, dimension is of basis or whatever it's called. Basically, the dimension remains same. So that essentially means like you can find one set of bases, you can find another set of bases for the same space, but the number of elements in that basis would be the same, the count of the bases. So that's true. So basis itself is not unique, but the number of elements in the basis is fixed, and that's essentially called the dimension of that linear map. Okay. Now the problem that we are talking about here in change of basis is that if we represented a vector, right? So we talked about in last class how we represent a vector is basically by taking the coefficients of the basis. Yeah, so I think this thing only, right? So when we assumed, so when we talk about, let's suppose this thing, right? This vector. So if we take this thing and this thing as a basis, we can represent that as, let's suppose, whatever the length of line is here and whatever the length of line we have on this axis, right? But let's suppose we want that to be represented on like by this. Uh, so yeah, so let's suppose we are taking the case of same vector here. So initially we wrote the coordinates of this thing as 2 May 100, right? And plus 3, let's suppose. And that this is how we represented the vector, right? So so now the question statement that we have here is key, instead of taking these two as a basis, we took this thing as a basis, let's suppose. Okay, where this is at some, let's suppose, rotated by angle theta. Okay. Now how do we represent the same particular line segment, right? So this is basically the change of basis problem that we're talking about. Like you can formulate this as a programming as well, like thing as well, but this is what the problem that we're talking about. So can anyone think of some solution to this? Like what are the things that we need to represent this, like this some random thoughts if we have to do this, and we know that this is a vector. Let's suppose we know in this particular basis this is it's like we know that we have the information on the vector, right? And let's suppose I gave you a new basis which is some let's suppose the basis vector rotated by angle theta. Okay, so how can we come up with new set of coefficients?
So first we will need to find x and y axis in that new basis, and then.
Okay. And when we say find, what does that mean? So when we say find, right, does that mean like writing something like this 20 or 02?
So first we will find how the new basis in terms of the older basis. Like
First we'll find new base in terms of older basis. Okay.
and from that we can find the matrix, and then that will help for every point.
So you said first we'll find new basis from old basis, and then from
Yes.
that what we'll do is
So we can make the matrix, and then from that matrix we can find the new position for every point, new
okay.
coordinates for every point.
Okay. Yeah, I think that's sort of correct. Anyone else has any other point? I think what Ritesh said is pretty much good way of thinking is that's basically I think one of the correct ways of thinking. I think what you can do is like you can represent that as another transformation, right? So essentially, like talked about clubbing of transformation, right? So this you can see this whole entire thing as one of the like combining two operation like two transformations. So one is like how I think it's basically you just need to find a matrix of that particular transformation, right? And then you're done. So if you multiply anything with that matrix, any vector with that matrix, that will move that to new basis. So think of it's like change of basis as like one transformation, right? So I think here we can clearly see like the transformation is basically a rotation matrix. So whenever you right, rotation matrix is essentially what some I think 0 0 cos theta minus sin theta minus cos theta is what I remember. But essentially, look at like just think of change of basis again as a transformation, which is linear. So if we know like it is a transformation, तो मतलब कि उसका एक matrix होगा, right? So all we have to do is just come up with a matrix for that, and then if you know the matrix of anything, right? Then essentially whenever you want to transform something, you just multiply it. That's it, right? So is this something which is clear? So in this particular case that we're talking about is basically a rotation transformation, and rotation transformation का जो matrix होता है वो ये होता है cos theta minus sin theta, some cos sin minus sin cos. I think this is, if I remember correctly. First of all, is this clear कि मतलब we can represent the change of basis as a transformation? We can think of it as a transformation problem. Any doubts on that? Okay, so this point is clear to everyone. Can anyone like everyone say yes if it's not clear on then?
I was watching the 3 blue 1 brown on this. I'll have to complete that.
I mean, you don't need your triple one bound Krishna. It's basically, I mean, see, if I say, like matrix can represent any linear transformation, right? So what are the linear transform? Few of the linear transformations that we are interested in, like one is like a rotation, okay? One is like a scaling. Let's suppose why is rotation and scaling a linear transformation is something that's very easy to verify, right? If you rotate some like if you rotate first by 60 degree and 30 degree, it's the same as rotating first by 30 degree and 60 degree, right? So that, and then if you rotate something by 2 times 30 degree, which is 60 degrees. So I mean, you can pretty much just verify using the properties. Yes, transformations are linear transformations. Now if there's any linear transformation, then essentially like effectively map that to the fact that we can always calculate a matrix that can represent that thing. Okay, when you're talking about a vector like vector space mappings. So यहाँ पे change of basis is what, right? Up, it's basically like I had shown you here, right? So it's basically as what I've done is just did a small rotation of the axis that we are talking about. Then the question here is like, if a vector was this, what would that vector be in this thing, right? So it's basically like just finding out the transformation and then just getting the resultant vector. So essentially it's like a map, right? So the map that the thing that we have been studying so far is the same thing. It's one of the application of the map that we're talking about. So you can think of it at that way. I think it could be one way
Okay.
to think. Yeah. Okay. So I wanted to, so change of basis, I think you can read it up. If anything is not clear, then maybe we can discuss. And there's one more thing. So there was this notes, this particular book that we have posted here, right? So I think there are some very good proof. I think specifically I'll just go through it, but you might just go through the questions here and see if you're facing any difficulties in any of the questions. So this is from mostly the vector span basis and all of that things that we covered. And this is, I think, chapter number exercise, I think 5th chapter. So this should I think help you guys clear out a lot of concepts related to like the things that we talked about previously. So just pick up all of like couple of questions from here and see if you can solve it. So I won't say like just to everyone, but at least pick up at least any 2 questions from this and see if you can solve it. And if you have any issues, let's just discuss. Let's just discuss it together and try to come up with the answers. Okay. So I think that's the first assignment that we have. So pick up. I think first part is calculation. This should help you a bit to remember like how we calculate things. So especially like you can just pick up any two, let's suppose any 3 questions here, and pick up any 2 questions from here. Okay, and then just post the answers or just try to discuss the answers. So let's have that by I think a day after tomorrow, and then let's discuss whatever we were stuck. Okay. So so I think make sure you do this. Okay, and then after this, I think this chapter is I think we have also covered this chapter. Wait, I think we have also covered this chapter. So I think you can attempt from here as well if you want, or you can give this thing a read as well. This would I think help you clear out a lot of things as well. It's the same thing that we are talking about. So chapter 5th and 6th I think we have covered. So this book, so whatever structure this book is following, that is what we are following. So essentially that particular lecture series is also following this whatever notes that we have here, and even MML book follows that. So I think the next chapter they have covered is I think eigenvalue and eigenvectors. We have switched that to determine. I think I didn't take determinants, so maybe I'll also go along with this book. So we can. So I'll take up this eigenvalue and eigenvectors next. So I think there are total 8 or 9 chapters in this book. 11. So spectral is mostly SVD. So yeah, so I think we have already covered till 6th chapter, I guess. So the remaining chapters are this only. So I plan to cover like 7, 8, 9, 10, 11 within like before 20, like in next 10 days. Okay. At least that's my plan. It totally depends on like how soon we are able to understand a lot of things. But yeah, so you can safely follow this book if you want, like if you want to go along with the classes. But yeah, so try to cover some exercises from 5th and 6th. Okay. And whatever questions you have, you feel like make sure you post it before, because there's a lot of stuff that even I don't remember, and I get to I just have a glance and then teach you guys. I mean, so I might have to look up some certain things to clear things out, right? So make sure you post that thing in advance so then even I have time to research and answer. Okay. So yeah, so I think tomorrow we'll mostly I think I was planning on covering the determinants, but what I'll do is like just follow the book and take up eigenvalue and eigenvectors. Okay. So make sure you also read it up. It's not that much. If you see, it's just hardly 10 pages. So it will, if you read this up, then that will also help us to take the lectures quickly. Okay. So I think for tomorrow, I think we have this like just read this eigenvalue and active. By the way, everyone is interested in daily lectures, right? Does anyone have any problem? Like anyone who cannot attend?
I think it will be like some days if one day I miss, then maybe next time I lose touch and I'm not able to catch up. So that is the risk.
Yeah, I understand that. Okay, so what we can do is like you guys can decide मतलब कि कब करना है फिर. Okay. See, I'll tell you how many lectures I need to cover this linear algebra. So I'll tell you. So assuming we have covered everything till 6th, this will take me eigenvalue eigenvector should take at least 2 lectures. ठीक है, इसको भी 2 lectures मान लो. ये जो चीज़ है थोड़ी बड़ी चीज़ है. This is more like a thing that's a procedure, मतलब जैसे Gaussian elimination. So उसमें I think norms orthogonality ये सब चीज़ें concept वाली चीज़ें हैं. This should be 1. This should, I think we discussed a brief about this here, so this should be hardly one. So 2 to 4 5 6. Spectral pay, I think it can take couple of three lectures, I think 3 or 4 lectures. So yeah, so there are like around 10 lectures of roughly 1 hour that I need, मतलब around 10 to 12 hours more that I need. So let me know, because 28 के बाद then I'll be directly available only on 15th or so. So I planned this to, अगर 10 lecture चाहिए तो अगर daily लेते हैं तो हो जाएगा. और we can see like अगर let's say एक दिन नहीं आता तो दूसरे दिन let's suppose we can take 2 hours a lecture or something. So you guys can decide accordingly like what suits you the most, and then let me know. Will that work? I've told you the number of lectures it will take.
Okay, या फिर रिकॉर्ड हुआ तो आई थिंक चलेगा, कि कभी मिस कर दिया तो ठीक है, फिर every day is fine.
Okay, so should we take this every day? Parvez said yes. So Krishna,
Yeah, I mean, Mayank, there are some days जो मेरे को पता है मैं पक्का नहीं रहने वाला उस दिन. So, I mean,
so let's
I'll
just keep
inform
it
you ahead.
alternate days for now. I think alternate days is fine, right? Let's see how much we can cover, I guess.
I mean, even daily is fine. Only thing is मेरे को अभी मतलब एक कजिन है, उसके शादी में जाना रहेगा 3 दिन. तो तब मैं नहीं रहूंगा, बट वो नेक्स्ट मंथ है, तो
Yeah, I think
वैसा रहेगा बस, ऐसा
ये
कोई
1.5
प्रॉब्लम
घंटे
नहीं
का
है.
सेशन भी अच्छा है. Can we take this 1.5 hours every alternate day? I think we can
Yeah.
do this. Is everyone fine with this?
Yes, and we can maybe decide which day to skip and which day to keep. Like one day before we can decide.
Okay, so let's do one thing. Tomorrow we'll skip the lectures. Tomorrow you guys decide and let me know क्या dates mutual है. So you can take a poll among yourselves or something. Okay, 1.5 घंटे का lecture रख सकते हैं. किस दिन पे लेना है ये भी रख सकते हैं. I am available till 28th. So that's basically 11 days, including like if we exclude this. I can have it on weekend. It's not a problem, but it's something to discuss among you guys. I think weekend पे 1.5-2 घंटे का lecture ले लिए तो शायद सही हो जाएगा. And if you want like weekend का रात ना बर्बाद हो तो we can have it during the afternoon or something as well if you want. That's also, I mean, I'm fine with that as well. Okay, so whatever the case may be, just let me know tomorrow. Okay, so for day after tomorrow, so let's attempt 2 questions from 5th chapter for proof, and 2 questions from 6th chapter for proofs. Okay, and let's just do that. Okay, and preferably I think it's better like since there are 5 guys, if you can pick up like unique set of things so that everyone can discuss like solution to every other question in turn. I guess that would help us cover like all of the questions. So maybe I think what the best way out is like you can pick up like post which questions you are attempting, and then subsequently others can decide like what to attempt. Okay, so I think any questions so far, so from what we have covered today? So except for that row thing, I'll clear that out tomorrow. And anything else?